Imagine for a moment that we have a fly right here, and there's a cup with a handle and a marshmallow. If we use this point on the mug as our reference, and we could draw the general position arrow for the fly. We use R for general position. Next, we could draw X and Y. So let me do this incorrectly and ask yourself, what have I done wrong? What is wrong with this picture? Oh yeah, I drew Y first. Once I returned to the origin, I need to draw X and then I connect Y to X. What I did above is draw X and then I connected X to Y, which is backwards. So let me try again. I return back to the origin. I draw my X arrow pointing to the fly. Then I draw my Y arrow pointing to the fly. Next, I can add theta back in. Now, let's say for a moment that the value of X is negative 20 centimeters. Let's do negative 30 centimeters. The value of Y is going to be positive because Y points up, and perhaps Y is positive 40 centimeters. When I tell you to find R and theta, you do this. You say R is the square root of 30 squared plus 40 squared, and if you work this out, you get 50 centimeters. The first thing, should I make R positive or negative? Should I add that in the way I sometimes do for X and Y? Well, let's slow down. Positive and negative, we only use those to indicate the direction. But how do we show the direction of R? It's not with positive or negative. Instead, we show the direction using an angle, a numerical value. So we'll always make R positive. We'll never make it negative. Don't use sign for the direction of R. Instead, use theta. And we've learned that the way we calculate theta is using inverse tangent of y over x. And you might think, okay, well, I need to put into my calculator. Negatives are really, really important. The value of y is 40, and it's positive. The value of x is 30, and it's negative. But here's what we're going to do. If you have inverse tangent calculations, make everything positive. The 30, the 40, doesn't matter if it's left or right, up or down. Everything is positive. Okay? So when you calculate theta, it'll be a positive value. Here's the reason why we're doing that. It's because we're being careless. Right now, if I look at my triangle, theta is this value right here in the triangle. And I haven't specified if this is the first quadrant, second quadrant. I haven't told us if the angle is, I haven't stated whether the angle is like this or like this. Maybe the angle is like this. So we've been really careless in our theta when we state the value of theta. What's coming down the road is a better way to describe theta. And when we use that better way, we will always need positive values of theta. So the trick we're using here, make theta positive, is something that becomes important when we learn the second step, but we haven't learned that yet. I don't know offhand, I think this is like 53 degrees or something, but let's say theta is 53, I haven't calculated this. That's where we're leaving our answer right now. But in another week or so, here's what we'll be saying. 53 degrees up from left. So we haven't added this piece. Don't worry about it just yet. But that's what's coming. And when we use that second piece for the direction, this is all the direction. Once we add that second piece, we'll always need a positive value of theta.